Let's graph this parabola. Notice it's actually in a graphing form already. Let's recite that from memory. Y equals A times the quantity x minus h squared plus k. Now, this type of graph is actually a function. So this parabola is a function. It passes the vertical line test. So instead of writing y, I'm going to write f of x. Remember, your input is x and your output is f of x. We need to identify the vertex. The vertex is h comma k. In this case, our vertex is -6, 4. And we need to plot 5 ordered pairs. So we have x and then another f of x. I'm going to make a 2-column t-chart with -6, 4 being the vertex. I need 2 ordered pairs left of the vertex. So why don't we try -8 for x and then -7 as well. And we could try -5 and -4. Let's find f of -8. F of -8. Well, f of -8 is -3 times -8 plus 6 is -2 quantity squared plus 4. So what is f of -8? F of -8 is going to be 4 times -3 is -12. -12 plus 4 is -8. Let's find f of -7. -3 times -7 plus 6, so we get -1 quantity squared plus 4. We get 1 times -3 plus 4 is actually 1. -5, you will also get 1. Yes. And then at -4, you'll also get -8. There we go. And we also have an axis of symmetry. Sometimes that will help you draw your parabola. Your axis of symmetry is the vertical line that goes through the vertex. So this vertical line is actually x equals -6. We'll go ahead and draw that as well. 1, 2, 3, 4, 5, 6 in a negative direction. I'm going to draw that axis of symmetry here as a dotted line. So there it is. And we're going to label that x equals -6. Remember, a vertical line is an equation. And that equation is x equals -6 for this particular case. We need -8. So there's -8. And then we need -8 down here as well. So that's -8. -8, we get an ordered pair -8. So right about here. Obviously, if you have graph paper, take advantage of it. Go ahead and use graph paper. That's always very, very handy. -7, we get 1. -6, we get 4. 2, 3, 4. Right about there. And we could use the axis of symmetry to plot our other ordered pairs. Makes it a lot easier when you just use the axis of symmetry like a mirror. And then, of course, play connect the dots. This parabola, because it's opening downward, there's an emphasis of having a maximum value. Can you see the maximum value? The maximum value is 4. So that's a very important observation of a parabola. Let's go ahead and circle the final answer. This final answer is actually your graph, which is right there. And let's circle your labels as well. Let's label the ordered pairs that you plotted. Whenever you graph, make sure you draw it with your own pencil, label all your ordered pairs, state any vertical lines or horizontal lines that are necessary, and then be detail oriented. Make sure you put the arrows at the end of your graphs as well, so that it matches your domain and range. Let's consider the following quadratic function, g of x. Write the equation in the form g of x is equal to a times the quantity x minus h squared plus k. Then give the vertex of its graph. In order to do that, we need to complete the square. And to complete the square, we first factor out the -3 so that we focus our attention to x squared minus 8x. I'm going to leave a space there to complete the square. I'm going to take 46 off outside that parenthesis. To complete the square, we take that 8 and divide it by 2. Take that 8 divided by 2, you get 4. 4 squared, you get 16. So we're going to subtract 48. If we subtract 48 on the right-hand side of the function, we need to make sure everything is equivalent to the function above. And the way we do that is add 0. So if we took away 48, we need to add 48 back. How can you tell that you took away 48? Well, you simply take -3 times 16. So you took away 48, and then we got to add 48 back. Now notice g of x is now equivalent to the g of x that was given. G of x is now equal to -3 times the quantity x minus 4 squared plus 2. And we know the vertex. The vertex is 4, 2. Because we know that the vertex is h, k. So we got one ordered pair from the parabola. We also know the axis of symmetry. That often helps us graph the parabola, so let's state that. Axis of symmetry is the vertical line. And how do we label vertical lines? We label it as x equals 4. So even though it didn't ask for the axis of symmetry, let's provide it because it will help us graph much easier. I'm going to go ahead and label the 5 ordered pairs with a t-chart. And we have one of the ordered pairs, 4, 2. So what's 2 units left of 4? Well, we could try 2 and 3. And then we could try 5 and 6. So let's find g of 2. G of 2 is the expression -3 times 2 squared plus 24. Make sure you put that 2 in parentheses and subtract 46. We get, what do we get here? We get -12 add 2, which is -10. Let's find g of 3. G of 3. See how much that is. That's -27. add 72, and then take away 46. Let's do 46 and 27. Let's see how much that is. That's 73. So this is going to equal negative 1. So we have negative 10, then we have negative 1, then we have negative 1, and then we have negative 10 again. Let's plot this parabola, or this parabolic function. Let's plot the vertex first, 4, 2. And this parabola is going to open downward. Let's plot 3, negative 1. That means we have 5, negative 1. And if it helps, draw the axis of symmetry. Usually we draw it as a dotted vertical line. And we could go ahead and label that. That's x equals 4. So that is the axis of symmetry. We need 2 more ordered pairs. Let's try 6, negative 10. And what else we have? 2, negative 10. So make sure you always graph your functions by hand before you use any software. So if you're doing your homework, have graph paper out, have a straight edge, have a pencil ready, have an eraser ready, and practice your mathematical drawings. Drawing is a mathematical skill. Labeling is a mathematical skill as well. So there you go. You've drawn your parabola. I'm going to go ahead and circle the final answer. We're also going to circle the ordered pairs because those correspond to the dots that you graphed. A school wishes to enclose its rectangular playground using 360 meters of fencing. Suppose that a side length in meters of the playground is x, as shown below. So the playground is going to be rectangular, and the left side and the right side here are going to be labeled x. So how much fencing is left? Well, there's 2 more sides, and there's a total of 360. So we're going to take 360, subtract 2x, and divide by 2. And then we know how much that is. We're going to take out a common factor. The remaining sides has a length of 180 minus x meters. Find a function that gives the area a of x of the playground in terms of x. Well, remember the area of a rectangle is length times width. So if you think of this as being the width and this as being the length, in order to get the area, we simply multiply these 2 numbers. So a of x is going to be x times 180 minus x. Why don't we write this in the form that allows us to see the vertex? Let's get it in this form. Let's get it in this form over here. I'm going to go off to the side here. And the form we want is a of x is equal to lowercase a times the quantity x minus h squared plus k. That way it yields the vertex, and we can answer the remaining question, or questions. The vertex is h comma k. Let's take the a of x that we have. It's 180x minus x squared. I'm going to rewrite this. I'm going to factor out a negative 1. And then focus on x squared plus 180x. We're going to complete the square by adding 0 to the right-hand side of the equation. So take 180, divide by 2. We get 90. You square it. You end up getting 8,100. But we subtracted 8,100. And so to add 0, we're going to add it back. That makes 0, and we're good. Let's rewrite a of x one more time. Rewrite the function a of x to be negative times the quantity x minus 90 squared plus 8,100. And now you can identify the vertex. The vertex is 90, 8,100. How does that answer the question in part B? What side length x gives the maximum area that the playground can have? The length that is needed to maximize the area is 90 meters. Don't forget your units. Always write your units on your paper. Always, always, always. And if the problem is taught to you in a complete sentence, you should answer it in a complete sentence. What is the maximum area that the playground can have? The maximum area that the playground can have is 8,100 square meters. Once again, do not forget your units. Always write your units on your paper first. Do everything on your paper first. So don't forget your units. Don't forget your units. Remember that labeling is a mathematical skill. Right here, we're not talking about miles. We're not talking about acres. We're talking about meters and square meters. So make sure you label your units. That is a scientific skill. A wire that is 48 centimeters long is shown below. The wire is cut into two pieces, and each piece is bent and formed into the shape of a square. Suppose that the side length in centimeters of one square is x, as shown below. Find a function that gives the total area enclosed by the two squares in terms of x. Let's look at the first square. The first square has 4 equal sides, so it has x, x, and x. Then how much wire is left? Well, let's ask that question. How much wire is left after the first square? You probably have answered it by now. It's going to be 48 minus 4x. So what's the side length of the small square, or the side length of the second square? We're going to take the remaining wire, which is 48 minus 4x, and divide it by 4. And that's very convenient. We can actually simplify this. And so the remaining side for the second square is actually 12 minus x. Find a function that gives the total area, a of x, enclosed by the two squares in terms of x. A of x, then, would be the sum of the two areas. That would simply be x squared plus the quantity 12 minus x squared. Why don't we go ahead and simplify this? A of x is now equal to x squared plus 144 minus 24x plus x squared. A of x is now equal to 2 times x squared. And we have minus 12x. And I'm going to put the plus 44 here. I'm going to go ahead and complete the square on the x squared minus 12x. Take 12 divided by 2, you get 6. 6, and you square it. I'm going to write a plus 36 here, but we need to add 0 to keep this balance. So I'm going to take away 72 on the outside. So I didn't really add 36. I added 72, and then we took away 72. Let's find our function now. A of x is equal to 2 times the quantity x minus 6 to the second power plus 72. That's the function we want. And because this is a parabola opening up, it's actually concave up, so it actually has a minimum value. Find the side length x that minimizes the total area of the two squares. Well, we simply read that from the vertex. Remember, a of x is now of the form a times the quantity x minus h squared plus k. This vertex tells you a lot of information. Our vertex is h comma k, specifically 6 comma 72. Let's see what the 6 represents. The length of 6 centimeters minimizes the total area from the two squares. What is the minimum area enclosed by the two squares? The minimum area enclosed by the two squares is 72 square centimeters. As usual, if the problem is written to you in sentences, you should write your answer back in sentences. Also, do not forget to write your units on your paper. Make sure you've written this down on your paper. Never type this in. Don't assume it. You must write it on your own so that you know how to label things. Labeling is a scientific skill. Let's circle all our final answers. The graph of a quadratic function with vertex -1, 1 is shown in the figure below. Find a range and a domain. Write the range and domain using interval notation. We know the vertex is -1, 1. And the domain of a quadratic function is a little bit easier to see. It's the set of all possible x values on this graph. So notice this graph is getting wider and wider and wider, and that's what the arrows are saying. So this is actually going to continuously get wider and wider and wider and wider. So all the possible x values is actually could get up to 3,604,852. And of course, it could go to the negative direction as well. So remember that the domain is the set of all x values. Let's call this function f of x. And I'm going to use the notation capital D-O-M, then parentheses, the domain of f is going to be written in interval notation, negative infinity up to positive infinity, which is all real numbers. Now to get the range, what you want to do is tilt your head 90 degrees to your left. And if you look at the range very, very carefully, I want to draw it right here. You can see that the lowest y value is getting lower and lower and lower. So the lowest value is very, very low because of the arrow. The arrow indicates that. So the lowest value, or the lowest y value, is very, 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 very large in the negative direction. So we call that negative infinity. That's not an 8, by the way. Remember, your head is 90 degrees rotated to your left. I'm going to put a comma. And it goes up to what? If you look very, very carefully, it goes up to -4, -3, -2, -1, 0, and the highest possible y value on this graph is 1. So it goes up to 1, and we actually include 1. Notice we don't include infinity, because infinity is not a number. Infinity is a concept. I meant we don't include negative infinity here, because infinity is a concept. So there's our range in interval notation. How do we write the range? I use capital R, N, G, parenthesis. The range of f is equal to negative infinity, comma, -1. Feel free to do example B on your own. You could pause the video, and if you need to check your answer, certainly unpause the video to see the revelation. First thing you want to do is call this function g of x. It's not the same as part A. The domain of a quadratic function is relatively simple. It will always be all real numbers, unless otherwise restricted, but this is not restricted. You can see that from the indication of these arrows. They're not restricted at all. Let's find the range. If you need to, tilt your head 90 degrees to your left. And the range of g, let's read the vertex from the graph. That's going to be key. The vertex here is 4, -2. In this case, because the parabola is opening up, the emphasis here is not a maximum value, but a minimum value. So if it's concave up, the parabola is going to have a minimum. But what is its range? Well, the range starts with that minimum value, so bracket -2, and goes up to infinity. And the infinity is a symbol that looks like an 8, but sideways. If you need to, you could always label it off to the side like this. 90 degrees rotated to your left. Another way of writing this is actually drawing an arrow to indicate those y values. Notice you're shading towards the concept of infinity. And you're shading from the bottom to the top. For part A, you actually shaded starting with negative infinity, and then you shade all the way until you get to 1. Let's circle our final answers. The function g is defined below. Find all values of x that are not in the domain of g. g here is a rational function. There's a polynomial in the numerator, and there's a polynomial in the denominator. We are very concerned with the denominator. Let's check it out. G of x is equal to x minus 3 over the quantity x plus 3 times the quantity x minus 3. Right here, this tells us a lot of information. This says that x plus 3 times x minus 3 cannot equal 0. We do not want 0 in the denominator. So x plus 3 can't be 0. And x minus 3 can't be 0. That means x cannot be negative 3, and x cannot be 3. That would answer the question. Let's answer the question just to be very, very clear. The values of x equals negative 3 and x equals 3 are not in the domain of G. There is a second and third part. So there are more examples. There's example B and example C. Find all values of x that are not in the domain of H. Once again, you tackle this problem by factoring the numerators. Well, I don't even need to factor the numerator. We just need to factor the denominator, because the domain of a rational function has everything to do with the denominator and not the numerator. The denominator here is x plus 6 times the quantity x plus 7. Yeah. So once again, x cannot equal negative 6, and x cannot equal negative 7. The values of x equals negative 6 and x equals negative 7 are not in the domain of H. Now we have a different function, different h of x, and we're going to start off in a very similar manner. X squared minus 16x plus 64 cannot be 0, right? I should have wrote that up here as well. We could factor this. This is a perfect square trinomial. So x minus 8 quantity squared cannot be 0. That means x minus 8 can't be 0. X cannot be 8. The value of x equals 8 is not in the domain of H. It's better to write a complete sentence for this particular problem just to make sure you understand how to answer the question. Find the domain of the function. H of x is equal to the square root of the quantity x minus 3. Write your answer using interval notation. For these types of functions, you just got to remember that you cannot take the square root of a negative number. In fact, we can only take the square root of numbers that are positive or equal to 0. And the way we write that is use the greater than or equal symbol. Write x minus 3 is greater than or equal to 0. Simply solve this inequality to get the domain. X is greater than or equal to 3, And we could just translate this to interval notation. 3 included, so you write bracket, and then let this run towards infinity. That is what we call the domain of H. Now we have a function named u of x, but it's also a radical function. Once again, you could only take the square root of positive numbers or equal to 0. So write negative 8x plus 32 greater than or equal to 0. Subtract 32 from both sides, and we get negative 8 times x is greater than or equal to negative 32. When you divide or multiply by a negative number for an inequality, be sure to switch the order on the next line. You're basically flipping the number line. So if you flip the number line, you're going to have to switch the order. So x is now less than or equal to positive 4. Let's write the domain of u. The domain of u is equal to negative infinity, and then you shade up to 4 and include it with a bracket. Make sure you show your work. I'm going to circle the work as well. It's very important that you show your work. Find the domain of the following function. We have to worry about the denominator and the radical. I want to first analyze the denominator. The denominator cannot be 0. So we write negative x plus 1 cannot equal to 0. That means 1 cannot equal to x, or x cannot equal 1. Now we'll analyze the radical. So first you analyze the denominator, and then second we're going to go ahead and analyze the radical. Remember, we could only take the square root of positive numbers or equal to 0. So x must be greater than or equal to negative 5. So we have this conjunction. X is greater than or equal to negative 5, and x cannot be 1. So how do we write this in interval notation? Well, we start shading at negative 5. And then we shade all the way up to 1, but we cannot include 1. So we're going to write a parenthesis next to 1. We could go more than 1. So we're going to write union, and then we continue shading. Write another parenthesis, write 1, and then we shade up to infinity, or we shade towards the concept of infinity. That's our final answer for part A. Why don't you go ahead and try part B? If you need to, pause the video, try the problem yourself, and then you could unpause it to check your answer. First thing we're going to do here is analyze the denominator. 1 minus 2 times x cannot be 0. That means 1 cannot be 2x, or x cannot equal 1/2. Now we're going to analyze the radical. Remember, for the radical, we could only take the square root of positive numbers or numbers that are equal to 0, or a number that is equal to 0. So 6 plus x is greater than or equal to 0. X is greater than or equal to negative 6. So x is greater than or equal to negative 6, and x cannot equal 1/2. Putting that together, we have we have bracket negative 6, shade up to 1/2, parenthesis, union, parenthesis, 1/2, and then shade towards the concept of infinity. Let's find a domain and range of both these graphs. Now you got to remember, domain is in the horizontal direction, or you could think of the domain as the set of all input values to your function. So a good way to remember this is that your domain is going this way, in the horizontal direction. Let's go ahead and read it from here. It starts off bracket -2, and you shade all the way up to 0 with parentheses. Then union what? Union parentheses 4 up to where? Up to 5 bracket. So the domain is the set of all x values that are on your function. So that is the domain of G. Let me write that. The domain of G is this union of intervals. Now how do you do the range? Well, if you turn your head sideways to your left, 90 degrees to your left. Turn your head sideways 90 degrees to your left. So have a crooked neck. And we're going to read the range values. The range values are all the possible y values on your function. So if you look very, very carefully, we don't have -4. So we're going to put parentheses -4. And it goes all the way up to 5. We certainly have 5, but we have more than 5. We actually have all the way up to 1. But can we include 1? And the answer is no. So we put parentheses on 1 as well. So there is your range. Your range of your function g is simply one interval from -4 to 1, but parentheses on both endpoints. Go ahead and try to do the second example, example B. You could pause the video, and then if you need to check your answer, unpause the video to see the revelation. Another hint for you guys is that when you do the range, you're reading from the bottom all the way to the highest possible y value. In this case, for example B, the highest possible y value is actually 0. Also notice in example B, there's a gap between what? -2 and -1. Notice there are no y values in here on your function. So that's why we excluded that. So we continued at -1, and you only went up to the y value of 0. The range is the set of all y values from your function. Or you can think of the range as the set of all y values from your graph.